Visible, sir.
Fine. So how you want to do revision? Means do you want to write down each and everything again, or you just
Sir, I will write down each and everything again.
again you'll write down? Okay then. Okay then. See here, mechanics is of two parts, kinematics and dynamics. Kinematics is nothing but a study of motion in one dimension and two dimension. Means wherever any object is moving, a car or a spaceship, space shuttle, or an airplane, or any train, a bus, anything which can move. If anything is moving, then the study of its motion is called as kinematics. And the study of cause of that motion is called as dynamics. That motion is dynamics. Okay. Now, in kinematics, first of all, we need to understand what is rest and what is motion. We cannot say, means when can we say that an object is at rest? Yes, can you tell me when can we say that an object is at rest? Is there anything such as absolute rest or absolute motion?
Sir, there is no word such as absolute rest and absolute.
There is nothing such as absolute rest or absolute motion. Like you are sitting on a table or chair right now, presumably. But are you at rest? Yes, with respect to your surroundings, you might be at rest. But what about the surroundings? What if the surroundings are itself moving? Surroundings are themselves moving. And yes, they are moving because Earth is also moving. Earth is rotating, is it not? It means you are also rotating. And if you are rotating, then how can you be at rest? It means you are at rest with respect to your surroundings, like a man sitting in a car. Okay, a man sitting in front seat and on the back seats, other family members are sitting. So, with respect to him, the other family members who are sitting on the back seat, they are at rest, is it not? The distance is not
Yes.
changing, but with respect to an outsider who is outside, who is a bystander, who is seeing the car moving, with respect to him, the car is moving. It means each and every person sitting inside the car is moving. Okay, okay. So this rest and motion, we will define them first of all with respect to the position. If the position is changing with respect to the surroundings, with respect to the time, with respect to the surrounding, with respect to the time, in that same frame of reference, in that same frame of reference. Okay, got it?
Yes, I got it.
So this is the definition of rest. An object, it will be said to be in rest or to be in motion when with respect to any frame of reference. Frame of reference, what do you mean by frame of reference? Yes, Hemant. Do you remember something about frame of reference?
You see, it's from where we are observing a point of some that is called frame of reference.
Frame of reference is the point of making observation, the point from which we are making the observation, like origin, where our origin is situated. That is our point of reference, and the location of that origin in the three dimension universe, that is called frame of reference. Got it now? Like the car in which you are moving. So that car is your frame of reference. You are sitting in the car, so you are origin. You will feel yourself to be at origin. But because you are sitting inside the car and car is moving, that's why your frame of reference is moving. Your frame of reference is car itself. If the car is stationary, your frame of reference is stationary. If it's moving, then your frame of reference is moving. Got it now?
Yes, I got it.
Now, When the position is not changing, yes, do you want to ask
Yes, sir.
something?
So nothing.
Okay, fine. So when position is not changing with time, the object is said to be at rest. When its position is not changing, that's it. Rest and motion again, they are relative terms, and absolute rest and absolute motion have no meaning. Why? Because with change in the frame of reference, the definition might change also. Definition is saying with respect to the frame of reference, and if frame of reference is moving, then everything is moving inside that frame. Okay, if a ball is moving in a car, or if a ball is stationary in a car, but if car is moving, then everything inside that car ought to be in moving condition, is it not?
Yes, sir. It's a moment.
Now next is position of the particle. Just now we defined when the position is changing, or when the position or location is changing or not changing, then we term the condition as rest or motion. But what is this position? How can we define this position in physics? In physics, position is defined mathematically as coordinates. Coordinate geometry you might have studied. Okay, so in three-dimensional coordinate system, we can define the location or position of any particle. The position can be depicted in Cartesian coordinate system like x-axis, y-axis, and z-axis, or as well as with polar coordinates. These are the Cartesian coordinates. Here we are seeing these are the Cartesian coordinates: x-axis, y-axis, and this z-axis. They are Cartesian coordinates. Any point P which is situated here at x1, y1, and z1, its position vector, or simply the position of point P with respect to origin, this is the location. Location we can define through position vector. Position of a particle can be defined through position vector. So you can write down also, can be defined with help of position vector. And what is position vector? Yes, what is position vector? Position vector just depicts the position of a particle. If a particle is at x, comma y, comma z, then the position vector, this OP vector, will be equal to x1 I cap plus y1 j cap plus z1 k cap. Okay, this is in rectangular coordinate system. Got it now? Writing down something, or shall
Yes,
we move
sir.
ahead?
Yes, sir. We can go, sir.
Yes, shall we move ahead?
Yes, sir. We can move, sir.
Fine, fine. Just tell me whenever you want to write anything. Okay.
Yes, sir. Okay, sir.
I hope you already have the notes along with you of all these things. Do you have them?
Yes, sir. I am here notes, I guess.
Uh, so okay, always take out your notes and sit with them. Okay, take a bunch of blank papers with you, and whenever anything we are going to do, any question we are going to solve, just add those pages after that topic. Okay, so
Yes,
that
sir. Okay.
you will be able to recognize while doing revision that this question was important, this question I did like that, this question I did like that. Okay, you would be able to recognize all of that, and the revision would be much easier. Fine.
Yes, sir.
Now, so these are the polar coordinates. What are the polar coordinates? In polar coordinate system, uh, only distance will be given to you and angle at which the point is located. Like it will be said that point P is located at a distance 10 meters at an angle of 30 degree from origin. So at an angle of 30 degree, first you will draw a line, and then on that line at a distance of 10 meters, your point will be located. Fine. That is the polar coordinate system. Whenever the angle and distance is given. So a point P is at a distance r from O at an angle theta. This is the polar coordinate. We write polar coordinates as r comma theta, distance comma angle. Okay. From these polar coordinates, we can find out the rectangular coordinates. How? Yes, how we can find out the rectangular coordinates?
Right,
Like this,
by
taking components, vectors you have studied. Okay, so as per the vectors, we are taking the coordinates r cos theta and r sin theta. Okay, in the direction of theta, we always take cos theta. Like whenever we are calculating this adjacent component, then theta is here on this side, then we will write cos theta. Okay, always remember that in the direction of theta, cos theta will be there, and in the direction
perpendicular
opposite to the theta, it is, or perpendicular to theta, it is sin theta.
sine.
Fine. Next, after that, we come upon types of motion. What are the types of motion? Motion can be described in several types. Here, we have listed a few only, like rectilinear and non-rectilinear. What is rectilinear? When the motion is along a straight line. When the particle is moving along a straight line, then it is rectilinear motion. Non-rectilinear motion, when it is not moving along a straight line, then it is non-rectilinear motion. Okay. Next is translatory and rotatory motion. Translatory motion means what? When the object is moving from one point to another. And rotatory means what? Rotatory means it is rotating at its own place. It is moving, but its position is not changing. Object is moving, but its position is not changing. It is rotating at its own place. Got it?
Yes, I got it. So,
Periodic and non-periodic motion. What is periodic motion? Periodic motion is when the motion repeats itself after a particular time interval. When motion repeats itself after a particular period of time, that is periodic motion. And non-periodic is when it is not happening in after a particular interval of time. Like rainy season is there. Earth is rotating around the sun. Earth is performing revolutions around the sun. Uh, and it takes near about 365 days. Hello, am I audible?
yes, you're audible. Sir.
Fine, fine. I thought that the internet got cut off. Okay, fine. So, periodic and non-periodic motion is what? Periodic motion is like the revolution of Earth around the sun. After every year, Earth will again come at the same position with respect to the sun. And non-periodic motion is what? Non-periodic motion is it is returning. It might be returning, but it is taking a different period of time at all. Like you are going to school and you are coming back, but at one on some day you are taking more time to come back, and on another day you are taking less time to come back. So it is not preordained that you will take this much time only to reach back your home. Got it? So it is not. It is more like a random motion, but not periodic motion. Next, we come upon distance and displacement. What is the definition of distance and definition of displacement? Distance is the length of actual path. Okay, length of the actual path. Like, see this curved path ACB. Its actual length, like you are spreading a thread from A to C and then C to B. Then the length of that thread will be the length of the path. Its SI unit is meter, and distance is a scalar quantity. It can never decrease with time. Got this? Distance is
So,
a scalar quantity. It can never decrease with time because it is a scalar quantity. It has nothing to do with the direction. Distance can be in any direction, and it will always be same in meters. You do not have to specify the direction while explaining distance alone. Next is displacement. Yes, what is displacement? Displacement is the length of shortest path. Length of shortest path from A to B. This is the displacement. Okay. Here AB vector is the displacement vector. This AB vector is displacement vector. This is displacement vector AB. Displacement vector will be given by this R2 vector minus this R1 vector. What is R2 and R1? They are the position vector of the particle. Position vectors of the particle at point A and at point B. Got it now?
sir, every time displacement means final position vector minus initial position vector, no, sir?
Yes, yes, yes. Final position vector minus initial position vector.
Sir, in every case, no, sir, that is applicable.
In every case, yes, yes. If you are calculating displacement, then in every case, initial final position vector minus initial position vector will give you the displacement vector. You want to write it down? Shall we move ahead?
Yes, sir, we can go.
Now, this is just the calculation of displacement. Okay, see this example. A point is located at A 2, 5, 6 is to be displaced to B at 2, 9, 10. Find out the displacement vector. Then final minus initial we will do that. And we'll get the displacement vector. It is 4 root 2 units here. Okay. Next is find out the distance and displacement of a particle if it moves from point A to point B. If it moves from point A to point B. Now, how to calculate that? See this from A to B, it is a quarter circle. Quarter circle means what? Means 1/4 of the circumference. So 1/4 of the circumference, which we did here, that will be our distance. And the displacement we will calculate with the help of either trigonometry or by this Pythagoras theorem. Okay, with the help of Pythagoras theorem, or you can also calculate with the help of trigonometry. Got it now?
Yes, sir,
Easy
got it,
question
sir.
this was. Similarly, this question, find the ratio of distance covered with respect to displacement. Ratio of distance covered with respect to displacement. Okay. So this ratio is yes, the ratio of distance covered with respect to displacement. Ratio is what? Half of the circumference divided by diameter. Diameter is 2r here. This is the diameter here. Okay. So we got our answer. Again, find the displacement of an insect. Under root of a square plus b square plus c square. We just calculated this diagonal. Okay.
Yes, sir, okay, sir.
Similarly, in this case, a particle is moving from A to B. Particle is moving from A to B, and just an angle is given, that it is making an angle of 120 degree at the center. And question was to find out the displacement. So displacement will be this AB vector. AB will be the displacement, and this one third of the arc, one third of the circumference will be distance. So this is the distance, and this will be displacement. Displacement from A to B is 2r sine theta by 2. 2r sine theta by 2, this formula you can use anywhere. This is a standard formula. 2r sine theta by 2. It is useful and very
I mean, it's a displacement when a body is moving in circular motion. In circle.
in a circular, yeah, obviously. It is for circular motion. Like whenever a body is moving in a circle, then the displacement will be given by this formula. And how did we get it? We just used trigonometry. We divided this triangle AOB in two smaller triangles, AOM and OMB. Okay, and the angle we assumed to be theta at the center. So the angle of triangle is theta by 2. So sine theta by 2 will be equal to x upon r. So x is equals to r sine theta by 2. So 2x will be equal to 2r sine theta by 2. That is our answer. Okay. Next question is, a wheel of radius r is rolling on the road. What will be the displacement of a point P in half rotation on the wheel? Yes, have you calculated this question? Hello?
I'm so lesson.
See this. This wheel is rotating. This wheel is rotating. And while rotating, what happened? The point which was on its lowest position, means which was touching the ground, this point it came up and it came at the topmost position. This point P came up here. It means how much distance horizontally it covered? Horizontally it covered the distance of half of the circumference. This is pi r, 2 pi r by 2. 2 pi r by 2. In half of the rotation, the wheel, half of the rotation of wheel, the point P is moving in the topmost position. Got it? Now, we need to find out the displacement. To find out the displacement, what we'll do, we will just draw a line joining these two positions of point P. Now we have here 2r, distance 2r, and here we have pi r. Pi r and 2r. Now apply the Pythagoras theorem. You will get the option C as answer. Got it now?
It's not about it, sir.
Now, speed. What is the speed? Speed is distance, rate of change of distance of a particle. Or we can say distance covered by a particle in unit time is the speed. Again, speed is a scalar quantity because it is rate of change of displacement. Sorry, not displacement, distance. That's why it is a scalar quantity. Its SI unit is also meter per second. And average, now we will see several types of speed. In those several types of speed, we will study four types here: average speed, instantaneous speed. Hello, am I audible?
Say you're audible, sir.
Fine. Average speed, instantaneous speed, yes, what will be the average speed? Average speed will be nothing but total distance covered divided by total time taken. Total distance covered divided by total time taken. Got it?
Sir, got it, sir.
This you might be studying since a long time. And it's instantaneous speed. Instantaneous speed is nothing but speed at a particular instant. We are calculating speed at a particular instant. Particular instant. What do we mean by an instant? How can we define an instant? An instant is a very small time, very small span of time. We denote it as dt. Dt is very small time. Generally, we denote a small time or change in time as delta t. But delta t is very small. That's why we use limit. We use concepts of limit. And what are the concept of limit? That delta t is tending to zero. We read it as delta t is tending to zero. It is not becoming zero, but it is tending to zero. It is going very near to zero. Still, it is not zero. This we write as ds by dt. So instantaneous speed is ds by dt, or differentiation of displacement vector. Sorry, not displacement vector. Differentiation of distance will give us speed, instantaneous speed. Next is velocity. What is velocity? Velocity is actually rate of change of displacement. Again, displacement is a vector quantity. That's why velocity will also be a vector quantity. Its SI unit is meter per second. One thing to remember, that whenever you are going to convert kilometer per hour in meter per second, then multiply 18 upon 5 with the kilometer per hour. 18 upon 20, 18 upon 5 with kilometer per hour, you will get meter per second. Okay, multiply get the speed in meter per second. Now, types of velocity. What is velocity? Rate of change of displacement. So it is what will be average velocity? Average velocity will be total displacement covered upon total time taken. Total displacement we are writing as delta r, and total time taken we are writing as delta t. So delta r upon delta t means r2 minus r1 upon t2 minus t1. Okay, fine.
Is it okay, sir? Understood.
Hello. Yeah, what happened?
Sir, understood, sir. Hello.
Understood? Fine.
Yes.
So you are getting all these things. We are revising it. Are you able to write them down?
Yes, sir. I'm writing the important points, sir. No.
Fine. Okay, then solve. Try to solve this question. In 1 second, a particle is goes from point A to point B, moving in a semicircle of radius 1 meter. Semicircle of radius 1 meter. What is the magnitude of average velocity? Yes, calculate it fast. You have 30 seconds.
Plenty. What a man. Jai Shri Ram, Jai Shri Ram. కంప్యూటర్ అంటే పెట్టేసుకో భయపడాకు ఈఎంఐ లేదే లేదా వద్దులేనా ఏ ల్యాప్టాప్ ఇచ్చిలే అంటాడు జగన్ నరేంద్ర ఏంటన్నా ఏమనుకుంటున్నాడు ఎడ్యుకేషన్ అంటే మా కదా నే అప్పట్లాగా ఫ్రీగా చెప్తాను తర్వాత గంటకు 3,000 అడుగుతుంది చూడు. ఆ? ఏం క్వశ్చన్ అబ్బా అంటే 3,000 కూడా చెప్పట్లే ఏమంటావా
Yes, what's the answer?
once again a particle moves from A to B on a semicircle
Hello.
of
Yeah,
radius
am I audible?
displacement అడుగుతున్నాడు ఇది రూట్ టూ వన్ సార్ ఇట్స్ రూట్ టూ నో సార్ సార్ ఇట్స్ రూట్
Yes.
టూ సార్
See, magnitude of average velocity. Velocity is it is covering a semicircle,
సార్
not a
ఇట్స్ టూ
quarter
సార్
circle. Okay,
సెమీసర్కిల్
it
ఇట్స్
is
టూ సార్
covering. Yes, for semicircle it is 2 meter per second because the diameter is 2 and it is covering it in 1 second. In 1 second, particle is going from A to B. So the answer is 2 meter per second. Okay. Again, this was same question. You would be able to do that. Yes, next question. Try this question now. A body travels the first half of the total distance with velocity v1 and second half of the total distance with velocity v2. Calculate the average velocity.
టూ వి వన్ వి టూ బై వి వన్ ప్లస్ వి టూ
2v1 v2 by v1 plus v2.
ఎస్ సార్
Fine. But how to calculate it? We will assume that half of the distance it is covering with v1. So x upon 2v1. We will get the time in covering first half of the distance. Similarly, for second half, we will get x upon 2v2. So total distance covered is x upon total time taken is x upon 2v1 plus x upon 2v2. We will take the x common, it will cancel out. We will get 2v1 v2 upon v1 plus v2. Next, like when velocity is given as a function of time t, whenever velocity is given as a function of time t, how can we calculate the displacement?
by integrating kind dx by dt and by integrating on both sides and
Integrating, no, differentiating.
so you should displacement also
Okay, yeah. For displacement, we will be integrating. For acceleration, we have to differentiate velocity.
yes sir
Yeah, second part is acceleration of the particle, and for acceleration, we have to differentiate. So, can you calculate it now?
yes sir, I can calculate sir
Fine. So, when we differentiate it, we will get the acceleration, and when we integrate it, we will get the displacement. Okay. When velocity, when we need to find out the velocity, how can we find out the velocity? Just differentiate it. You will be able to find out the velocity. Okay.
yes sir obviously
When velocity is given as a function of x, when velocity is given as a function of x, then we need to use integration. Okay, dx by dt is velocity. This is equal to f of x. Then we take the terms of x on one side and terms of time on another side, and then we will integrate both. Like v is equals to x square is given in this example, and it is said that find out the relation between x and t. Then we did the same as we learned above. We will integrate it, and we got the relation x equals to 1 upon 1 minus t. Okay. Now, acceleration. Object. Whenever the velocity of moving object changes, then we say that it is under acceleration. The body is accelerated. Same terms for acceleration and same types of acceleration we'll study here. Average acceleration and instantaneous acceleration. For average acceleration, it is final velocity minus initial velocity divided by the time interval. Okay.
Yes, sir. Okay, sir.
So v2 minus v1 upon t2 minus t1. Again, acceleration is a vector quantity. It will be positive if the velocity is increasing, and it will be negative if the velocity is decreasing. Instantaneous acceleration is same as that of instantaneous velocity, means differentiation of acceleration with respect to time. Differentiation of velocity with respect to time. It will give us the instantaneous acceleration. Now, here we can use some properties of derivation. What are the properties of derivation? Like dv by dt is written, it means, and velocity is nothing but differentiation of displacement. It means we need to differentiate the displacement twice. That's called double differentiation, d square x by dt square. We will get instantaneous acceleration. And also, dv by dt is there, and dv by dt can be written as dv by dx multiplied by dx by dt. This dx and dx will cancel out ultimately. So we can write it like this. dx by dt is velocity. So v dv by dx is another formula for instantaneous acceleration. Thus, for acceleration, we got these three formulas: dv by dt, d square x by dt square, and v dv by dx. Okay, these are the three formulas for acceleration. Again, remember that acceleration is a vector quantity. Its direction will be same as that of the direction of vector quantity, direction of change in the velocity. In whatever direction the velocity is changing, in that direction acceleration will be there. Negative acceleration is also called as deceleration or retardation. Next is equations of motion. These equations of motion are only for constant acceleration. If the acceleration is constant, only then we can apply these equations of motion, otherwise not. Derivation of these equations of motion, you might be knowing them already. Hello?
Yes, sir. I know, sir. Yes, sir. I know.
You, you know the derivation? We do nothing, we just use integration here, integration and differentiation. Integration, like we know that acceleration is dv by dt, we take dt on other side and we integrate. Okay, hence we got v equals to u plus at. Second equation of motion, we use velocity as ds upon dt. Instead of velocity, we will write v equal to u plus at. We use that, and then we integrate, we will get our second equation of motion. For third equation of motion, we will use acceleration is v dv by dx, and when we will integrate it, we will get third equation of motion, v square equal to u square plus 2as. Got it now?
Yes, sir, got it, sir.
Now next is this example. Okay, try solving this example. Okay, yes, it's 7 p.m. now. Okay, so now we will start our optics.
Yes, sir, no worries.
Okay, so is it fine? Is it fine the pattern? We just revised all of this kinematics only. We were able to revise it only. And after that, I will send you some questions of advanced level.
Yes, sir. Yes.
Okay, and we will solve them in our class. Fine?
Yes, sir, okay, sir.
Okay, fine. Okay, then you can take a break of 5 minutes.
Yes, sir, I have the answer after mine.
You have what?
I will rejoin again after 5 minutes, sir. Yes.
Rejoin. No, you can you can remain joined in the class.
Yes, sir, okay, sir.